Good morning, students. In lecture number 5, today I will discuss exercise 2.4, question number 1, part 4. Question is, determine which of the following polynomial has x plus 1 is a factor. In fourth part, this is your dividend. P of x is equal to x cube minus x square minus 2 plus root 2 into x plus root 2. How can you check that x plus 1 is a factor? Student, when I had discussed basic of this exercise, I had discussed first of all you will find the zeros of divisor x plus 1. You will get minus 1 and put this polynomial, this zeros in this polynomial. If after putting remainder equal to 0, then you can say that x plus 1 is a factor. If remainder is not equal to 0, then you can say that x plus 1 is not a factor. You see, in place of x you will put minus 1 here, minus 1 cube, minus same, minus 1 square, minus 2 plus root 2 into, in place of x minus 1 plus root 2. Then minus 1 cube, you know very well, minus 1. Minus 1 square 1 into minus 1, minus 1. Minus into minus, you see very attentively, plus it will be same, and then plus root 2. Minus 1 minus 1 minus 2, bracket, you open this, 2 plus root 2 plus root 2. Minus 2 plus 2, they will be cancelled out, and root 2 plus root 2, 2 root 2. So after putting P of minus 1 here is not equal to 0, then you can say that x plus 1 is not a factor of P of x. This polynomial. Clear? Then question number 2 is same in question number 2. We use factor theorem to determine whether gx means divisor, is a factor of P of x, means dividend, in each of the following case. Here we take third part. P of x, you know very well, x cube minus 4x square plus x plus 6. Zeros of this divisor gx, x minus 3 equal to 0, x is equal to 3. Put here in place of x 3 cube minus 4 3 square plus in place of x 3 plus 6 3 cube, 3 into 3 into 3, 27. 3 3 ja 9, 4 ja 36 plus 9, add together, and 27 plus 9, 36 minus 36 equal to 0. After putting remainder equal to 0, then you can say that by factor theorem gx is a factor of P of x. It is clear? Factor theorem you know very well. Then part question number 3, find the value of k if x plus 1 is a factor of P of x. It is given that here x minus 1 is a factor of P of x. So you use here factor theorem. P of x you know very well. It is given that here x minus 1 is a factor of P of x. By factor theorem, P of 1 must be 0. Zeros of this divisor x minus 1. What is the zeros of x minus 1? X is equal to 1. So you put in place of x 1, 2, 1 square plus k into 1 plus root 2 equal to 0. Because if x minus 1 is a factor, then remainder must be 0. You put here 0, 1 square 1 into 2, 2, k into 1 k plus root 2 equal to 0. Then k is equal to, you transfer this minus plus 2 into minus 2 plus root 2 minus root 2, and here minus sign is common, here 2 plus root 2 is the value of k. So this question is also very very important. You see very attentively, and other part you can do yourself. So I have completed question number 1, 2 and 3. Other questions you do yourself. Thank you.